Hi guys, Mrs. Rossi here. Today we're talking about acids and bases. You should have your acids and bases note sheet, and I want you to follow along as we talk about them. At any time, if you need to go back in the video or pause it to fill in stuff, make sure you do that. All right, so first things first, we need to get our definitions of an acid and a base. So an acid is a compound that produces hydrogen ions, so H pluses, positively charged, because they have that one proton, when dissolved in water. So when you put an acid in water, it's going to give up those H plus ions. A base, on the other hand, is a compound that produces hydroxide ions. Those hydroxide ions should be familiar to you back when we did polyatomic ions. So OH, and that whole thing has a negative charge. So when you put a base in water, it produces those OH ions. Some properties of acids, which probably are pretty familiar to you, they have a sour taste. When they react with bases, they form salts. That's how you make ionic compounds. You can conduct electricity in an aqueous solution, which is also a property of ionic compounds, so that should not be that surprising. And they can react with active metals to give off hydrogen gas. And actually, during our chemical reactions lab, we did just that. There are some indicators, like red litmus paper. If you test an acid with red litmus paper, it will remain red. It will just look like it got a little bit wet. And if you test blue litmus paper, which is another indicator with an acid, it will turn it to red. So some common acids that you probably know of are vinegar, and its chemical name acetic acid, lemon juice, soft drinks, battery acid, stomach acid, black tea, apple juice. Pretty much most fruit drinks would be examples of acids. Speaking of acids, let's go back to our nomenclature unit. So we're going back to the beginning of the year when we had to name acids. So remember, all acids start with H, and if it's bonded to just one other thing, that's when you add the prefix hydro, so just one other element, prefix hydro, and it gets an ic ending with acid at the end. So for HF, F is just fluorine, it's not a polyatomic, so it becomes hydrofluoric acid. Same thing if it's just H bonded to chlorine, so just a hydrogen bonded to a chlorine. It's only that single element. It's not a polyatomic, so it becomes hydrochloric acid. And our polyatomic ions are back. Remember, you add enough hydrogens in front, because that's how we know it's an acid, to cancel out whatever the charge on that polyatomic ion is. And remember, when we're naming them, if it's an ite ending, like sulfite that we see in this first example, it becomes us. And if it has an ate ending, like nitrate that we see in the second example, it gets an ic ending. So sulfite is SO3 with a -2 charge. So it becomes H2SO3, and the name is sulfurous acid. In the case of HNO3, you know NO3 has a -1 charge, so there's only one H out front there to cancel it out. NO3 with a -1 charge is nitrate, and when you put that H out front, it becomes nitric acid. Here are a few more for you to try. You can pause it and give yourself a minute. Some of these should look familiar to you. Well, actually, they all should look familiar to you. We also have formula writing. All right, so HF, that should be an easy one. It's just hydrogen bonded to that fluorine, so it's hydrofluoric acid, just like in our last example. HNO2, so NO2 with a -1 charge is nitrite, so that would be nitrous acid for HNO2. And then we have H2SO4, so H2SO4, SO4 with a -2 charge is sulfate, so this would be sulfurous acid. Sulfuric acid, sulfuric acid. Us would be if it was ite, so sulfuric acid. And then to write the formulas, phosphoric acid. So phosphoric, and I gave you a hint on your sheet, comes from so ic goes back to 8, so you have the phosphate ion, PO4 with a -3 charge, so your formula would be H3PO4. And then hydrobromic, bromine, and hydro up front, you know it's just bromine that it's talking about, So it would just be H, 1H, because bromine has a -1 charge, HBr for your formula. All right, flip your page over, and we're moving on to some base properties. So bases are opposites of acids. They have a bitter taste. When they react with acids, they also form a salt, an ionic compound. They feel slippery to the skin. And with red litmus paper, it would turn it blue. And if you tested it, so with a different indicator, blue litmus paper, it will stay blue. Some common examples of bases include all of your cleaning products, sodium hydroxide, bleach, hand soap, laundry detergent. Anything that really feels slippery when you touch it is most likely a base. When you encounter something and you're not sure if it's an acid or base, or if you want to get a better read if it's a strong acid or base, you are going to use an indicator. The indicator is used to measure the pH of a substance, and there's many different types of indicators that you can use. A pH meter is one. It gives you a digital reading and probably by far the most accurate. This is something that they use for soil tests and even to measure the pH of blood. Litmus paper, we've talked about a little bit, and over here is a good way to remember it. Acid, red, base, blue, so it's the D's at the end of acid and red should be a reminder, and the B's at the beginning of base and blue. That should be a reminder for what happens with which type of litmus paper. So there's two different types of litmus paper. There's red litmus paper, and there's blue litmus paper. And to get an accurate reading, you'd want to do a test on each substance with both of them. So red litmus paper would remain red if it was an acid, and then if it was a base, red litmus paper would turn blue. On the other hand, blue litmus paper would turn red if you were testing an acid, and it would stay blue if you were testing a base. So this is kind of a good clue to give you an idea if you're working with acids and bases. Right now, you have the rest of this worksheet to work on. There's a little bit of clues about red and blue litmus paper and if they conduct electricity or not to identify something as an acid, base, or neutral. So take a minute to fill out number 11's chart, and then number 12, I just want you to sort out those acids and bases to figure out which is which, and we'll go over them in class together.